Ours is going to be the only system in the world where all of the primary data from the beamlines, every frame, will go into the store and will be there. So this is an absolute world first.
So we are the first production persistent data store and open data for a synchrotron.
I'm here at the synchrotron, and we're a user facility, and I run 2 of the 9 beamlines. So 2 of our beamlines are about protein crystallography, about solving the atomic structure of proteins. And when you can solve their atomic structure, you can understand how they work. And that's really important. So, for example, earlier this year, the structure of the insulin receptor with insulin bound to it was solved using our beamlines. And that's a landmark discovery in the control of diabetes. And for us, it's all about data. Everything we do is about data.
They want to focus on facilitating great science. They want to focus on running a 24-hour-a-day facility.
The whole point of Store.Synchrotron, the store, is that researchers can give access to each other while they're working on a project. So for them, they don't need to worry about backups, because we always get these, sad emails from people, their hard drives died or their DVDs are corrupt. Do we still have the frames for a project? And so we, a couple of times a year, we'll be digging up archive data to give to them because they've lost the media or the media is being destroyed. To give you an example, it can take 3 to 5 years to produce a protein crystal. And so the value of the data is in the hundreds of thousands of dollars for a data set that leads to a protein structure.
I think over 12,000 data sets have been collected already now. And so that's the really, I guess, important part, because we're not just saying these are files being transferred to storage. Each data set has its own context. We know who it is, we know when it was collected, what sample it was, everything to do with it. It's all organized, it's all online. It's all shareable from the get-go.
And so it's about taking the data which the taxpayers funded through granting agencies, protecting it so it doesn't get lost, making more efficient use of it between researchers, allowing it to be reused by other researchers. A lot of the granting agencies like NHMRC and ARC are wanting the raw data from the research they fund to be made publicly available. So other researchers can use it. And so I see RDSI as being a critical part of that.
If that's all taxpayer funded and public research, then if the publication comes out and everyone can see the result, then they should really be able to see the full story behind that data. The real function here is the entire stack of infrastructure that's being created. We're looking to RDSI so early in the process that we've designed a lot of our mechanisms around suiting RDSI. And the requirements really aren't stringent. They just want data sets of note that are shareable and are discoverable. If you want to publish open data, or you want to open up your research data, that this is not hard to do now. And all you have to do basically is say that one, and I want it published in a week, please. And that's opened up. And they can just grab the link and go, boom, there it is. And to get to this point is the hiding of a lot of complexity in the back that these researchers never have to see or care about. And that's the beautiful thing about it.